Good afternoon, grade 12. So, today we will be doing the other functional groups and homologous series. But before we do that, we have to do something that I've skipped before. But now I think so we have to talk about it. So, we have, as carbons, I was not naming them previously, but it's namakami carbons as lapable. So, basically, we have a primary carbon, we have a secondary carbon, and we have a tertiary carbon atom. Ne? So if we read up le part le primary carbon, a primary carbon is attached to only one other carbon atom, which means every carbon atom here that is attached to only one carbon atom is a primary carbon atom. So in this molecule, it is according to rule Z, it's supposed to be 2-methyl pentane, according to naming rule Z. Anyhow, that is not important. What is important is we want to find upper band with structure a carbon that is attached to only one carbon atom. So if you look at carbon 1 is only attached to carbon 2, and because of that it counts as a primary carbon. And if you look at carbon 5 also counts as a primary carbon because it is only attached to carbon 4. And then if you look at this carbon, now we may call it a primary carbon. Why? Because now it is only attached to carbon 2. The reason I did not number it is because it's not part of the main continuous chain. However, now technically speaking, it is a primary carbon atom. So we have 3 primary carbon atoms here. I am just going to write as is name number. So primary carbon atoms here, primary C atoms are C1, C5, and C, low methyl. So there are 3 primary carbon atoms here. And then if we say a ruler, we will see that we have secondary carbon atom. So a secondary carbon is attached to 2 other carbon atoms. So if you go to a structure say 2, there are how many? Technically speaking, 2. I will briefly say 2. Which ones? C3. C3 attached kubani ku C2 no C4. Technically speaking, we apply as a secondary carbon atom. And then also, if we look at C4 attached to C3 and C5. So basically, we count an I as a secondary carbon atom. So we have 2 secondary carbon atoms here. Ubani? Secondary atoms are C3 and C4. And then we have a tertiary carbon atom. So if you look at here, a tertiary carbon atom is attached to what? To 3 other carbon atoms. So it is bonded to 3 other carbon atoms. So if you look at the structure C2, C2 is the only tertiary carbon atom there. Why? Because we attached to C1, we attached to C3, also attached to C low methyl. So basically, that is a tertiary carbon atom. So a tertiary carbon atom, a tertiary C atom is C2. Yeah, C2. Full example. Ne? So I wanted to erase that. So anyhow, that's the case. Yeah, nansi ke ngoku enye into endifuna uyi-eda uzondiva ndiyisebenzisa le term. Sometimes le carbon ilapha ekuqaleni nasekugqibeleni, we call them terminal carbon atoms. Basically terminal, if you look at the dictionary, it's something that is situated at the far end. So terminal carbon atom. So if bendibhala ndisuka left ndisiya right, this would be my terminal carbon atom. If bendibhala ndisuka from right ndisiya left, this would be my terminal carbon atom. Uzandiva nje manje ndisebenzise lo gama, you don't have to define, but that is the kind of terminology we use, but we'll never be asked to define that. Anyhow, very important, primary carbon atom attached to only one carbon, secondary carbon atom attached to 2 other carbon atoms, then the tertiary carbon atom is attached to 3 other carbon atoms. This is very important as it is affected. We are going to use such terms when we refer to different types of homologous series. For example, the alcohols, the terminologies are often about alcohols, but I will get into it. So let's get to our examples. Homologous series. Homologous series here to color that we're getting into, it is going to be alcohols. So alcohols. So basically, alcohols are a homologous series of organic compounds, people. And because it's a homologous series, it means that there's a functional group that you will recognize. But alcohol. So the functional group of alcohol or alcohols, we always see OH. So OH attached to at least one carbon atom. According to Baba by 2, but as long as OH or 1, that makes that organic compound the alcohol. And la OH kasimbizayo unegama lakhe la OH kasimbizayo, I think it's familiar, hydroxyl group. We call that a hydroxyl group. And then each general formula of alcohols, it is CnH2n plus 1 OH. So that's the general formula of alcohols. Then the suffix, when we name them, sigqibela ngabani ekugqibeleni? Sigqibela ngo-ol. Ngo-ol. From la gama lithi alcohol. Yabona mosapho? Yeah, so ol. That's what the name ends with. Ol ekugqibeleni. And then we get to the next homologous series, which is aldehydes. So functional group of aldehydes, remember when you draw a functional group, by the way, you don't put hydrogens here. Had I put hydrogens here, that would not make this now a structure of a functional group like it generally. It makes this a specific alcohol now. Yabo. So we don't put hydrogens there. Anyhow, so it's going to be C double bond O no H. Mamela ngoku. Lo C double yabona le functional group is always, people, at the first carbon from the left. Basically it's always at the terminal carbon. La terminology selokhu isecaleni masibe kanjalo. This functional group is always on the sides. Sayibona nawe when we do examples. So ngu C double bond O, noba la H ndimbeke ngaphi, it doesn't matter. As long as ku C double bond O no H, funeka kubekho le part qa nebalulekileyo. And the name of that functional group is 4-myl group. So it's the name of the functional group of aldehydes. It's 4-myl group, and it's important that we know or we practice the names. The general formula is CnH2nO. The suffix ligqibela ngabani igama ligqibela ngo O I. ligqibela ngo-Al, yeah, Al. Sometimes ezinye i-textbooks zithi zigqibela ngo-NaL, yeah. But basically usuka phi la Al, usuka pha from the word al. I think usuka pha lo Al luka aldehydes. Ngandibuza babe kuthini i-alcohol yona izazoqala ngo-Al. It would confuse xa zoqala if you use la Al alcohols and then you use Al aldehydes. Anyhow, let's go to the next homologous series, which is ketones. Ketones very similar to aldehydes, but there's one key difference. So whenever you see double bond O, however la C double bond O is always ebona le carbon le so loku secondary carbon le ina la C double bond O, secondary carbon. Khumbula secondary carbon ethane attached to two other carbon atoms, yeah. So basically because of this ithetha ukuthi londo the ketone with the lowest number of a ketone, like eyona ketone in a carbon ezimbalwa, would have 3 carbons. Why? Because kunyanzelekile le carbon lena lo double bond O always attached to 2 other carbons. Because of that, it means that we don't have a ketone in a carbon E2, we don't have a ketone in a carbon E1. Because immediately in a carbon E1, that's gonna make it benje, yabo, izabanje. Then it be aldehyde. Also na 2, that will make it an aldehyde. Anyhow, the functional group nansi apha le part le is this part, and the name of that functional group is called a carbonyl group. Carbonyl group. So what's the key difference between carbonyl group and a formyl group? Is that always when a formyl group la C double bond O attached to a hydrogen. Apa kwi carbonyl group la C double bond O ukwi secondary carbon. That's the key difference there. And then the general formula CnH2nO. I'm well aware that ziyafana. We will explain when we do structural isomers. We will explain about what is happening here when we do structural isomers. Anyhow, kwangoku ziyafana. Their suffix, it's taken from this section of the name, la own, ketone. One. So we end our name with own. And then the last one for the time being, because we also have the other one which I'm not going to add here because I don't want to complicate things thus far. Anyhow, it's going to be carboxylic acids. Yeah, carboxylic acids. So Zona, what is the name of their functional group? Kukolo C double bond O nalapha ne? But now that C double bond O is attached to a C hydroxyl group. So basically, it's a combination of C double bond O no C 2 bond ka OH. So yonke le part li is the functional group li. All carboxylic acids have this section in, whether it's on the right hand side or on the left hand side. What do I mean by that? Whether imekanje people or imekanje, it is always, there will be that carboxylic, that functional group there. Its name is the name is carboxyl. What is it, Kanin? It is carboxyl group. Makes sense. Carboxylic acids sine carboxyl group. At least unanokuyahambelana. And then their general formula is CnH2nO2. O2. So basically, it has 2 hydroxygen atoms in the structure, hence O2. Then these 2 aldehydes, ketones, they have 1 oxygen, hence la O. Then zona alcohols, they have 1 O, but OH, hence their general formula looks like that. So the ones, most of the time when we want you to use the general formula to look for a molecular formula, kuzube kuko 1 functional group in the structure. Otherwise, if there are halogens attached to an alcohol, umzekelo okanye attached to a carboxylic acid or aldehydes, we will not be doing that. The molecular formula for us grade 12s. Anyhow, you grade 12s. Anyhow, let's do examples. So example 1, we recognize. Remember other rules apply as well. So you may go to Siyavula wako and then you just work with me okanye as ubukele now. Anyhow, so we have our structure. Looking for something. So we recognize the functional group immediately. OH, that makes it an alcohol, number 1. So now we will ask ourselves, if the alcohol and the main continuous chain containing the functional group is just a straight chain, that means that we go to the next part. We number such that that functional group is part of the main chain, as long as chain straight bantu. So number the closest functional group. Remember, it must have the lowest possible number. So we say 1, 2, 3, 4. And because of that, if functional group equal to, then when we name sizauti, by the way, okay, I don't say space here. Let me just write. So ngokusauti sithi kuzo zonke ezi homologous series that I've given you. Asisuthi math ne. Sathi methane 2 city, ethan 3 city, propan 4 city, butane 5 city, pentane city 6, hexane 7, heptane 8, city octane 9, nonan 10, decan. So basically those are our new prefix. For the time being, these are our prefix now. So it's Angela an we are kapel. So I'm going to be using that terminology here. So who follow, that means about butane. Butane. Then where is the functional group at carbon 2? Remember, alcohols, they end with the suffix ol. So butane to ol, basically. And if you remember, each general formula has been CnH2n plus 1 OH. So it's always about C4H, 2 times 4, 8, 8 plus 1, 9, 9 OH. Now we are balanced. It's going to correspond to this molecular formula. I'm not going to do for all. I'll just do every time we do the first homologous series. Hence, I'm not going to do for this one. So for this one, this is 1 carbon methane. Methane. Because position like in carbon E1, functional group also looking like carbon E1. So we just say methanol. Methanol, people. Yeah, very poisonous substance, methanol. Anyhow, silule. Very, very poisonous. Silule. This alcohol is, carbon Z3. So it's going to be propan, 2 all people. This is it clear? Now interesting, we are finding now there's 1, 2 functional groups identical. Khumbule sa apply the rules. Xa sibalayo apha sizawubala kweli cala li-closest. If ndiyisike siphakathi le molecule, uyoqaphela that the functional groups are on the left hand side. So xa ndibalayo ndoqala left, ndithi 1, 2, 3, 4, 5, 6, 7. The longest continuous chain has 7 carbon atoms, because if bendiphile apha these are about 5. So now sithini, sine-methyl phaya, funa siyimenshini uba kwi-methyl iphi carbon 4, so ngu-4 methyl, ne? 4 methyl ntoni kanene, izawuba i-4 methyl hept 7 hept. Now we must mention the positions of that arm. Remember, if a functional group appears twice, now you have to treat it substituents. Mention the position twice. So sizothi apha 3,3 ndoni die. Remember to die all. So i-4 methyl hept 3.3 die all. Yeah. Before that, I want to add an extra example here. Let me just put it on here because and it's bonus space. So I'm just gonna call this for this. Let's say 4A. This example, let's call it 4B. So I thought we'd have the example, but I don't see it there. Okay, this example is very important. So if I count here, 1, 2, 3. Basically, it's methyl happening. So if we name this molecule, this is how we're going to name it. 2 methyl. Nansi methyl data ngayo. Xa ndibala continuously ndisiya ngapha. That's going to be a methyl, a branch. 2 methyl propan, propan 2 all, ne? Because the functional group is carbon 2. Then now let's get something, because something. Let me provide space here before I talk about the different types of alcohols. Yeah. So let's read here. So apa kutwa we have 3 different types of alcohols. So these are types of alcohols. So if you look at example 1, I mean a primary alcohol. So basically a primary alcohol la OH, let me just read. OH is bonded to a carbon that is only bonded to one other carbon atom. Basically OH attached to a primary carbon. So umzekelo apa of a primary alcohol. Where is it now? Okay, I don't have. Because of that, let me just give you an example of mine. Okay, so an example of a primary alcohol will be like this: CCC. Yeah, so OH attached here to a carbon that is only attached to one other carbon atom. Because of that, this molecule qualifies as a primary alcohol, because le carbon ibambelele ku-OH ibambelele kwi-carbon A1 only, and it wouldn't matter noba ichain lide kangakanani people, it wouldn't matter. What matters is that the carbon attached to OH is only attached to one other carbon atom. Hence bendisebenzisa terms ke ngoku eziyazi ka-primary no secondary, because we can just say tina that OH is attached to a primary carbon, hence we call it a primary alcohol. So this is a primary alcohol, EG. This is a primary alcohol. And then let's do a secondary alcohol. OH is bonded to a carbon atom that is bonded to two other carbon atoms. So umzekelo we secondary alcohol nanku lu, which show napalm was butane 2-ol. I think they are saying yes, butane 2-ol is an example of a secondary alcohol. Why? Because lo OH ubambelele ku secondary carbon. In other words, ubambelele attached to a carbon that is attached to two other carbon atoms. That's what that means. So that's the example, butane 2-ol. Nansiya. So manibhale apha by secondary alcohol. And then now sizekli ithini tertiary alcohol. So tertiary alcohol ithini yona, OH is bonded to a carbon atom that is bonded to three other carbon atoms. So example yalapha ile bendiyenza apha nansi, I think basho napha ile example yethu bathi yi-2-methyl propane 2-ol. So if you look at it, 2-methyl propane 2-ol, the carbon atom attached to OH is attached to 1, 2, 3 carbon atoms. Hence they call it tertiary alcohol. So this is the tertiary alcohol. So yeah, tertiary alcohol example. Anyhow, you just ask. It's always as 1 mark type question. Anyhow, silule. So you need to be able to distinguish the different types of alcohols. Anyhow, silule ngo sizi up. Lena molecule. Do you remember I said C double bond O or no H, and you will find this on the terminal carbon atom, either ecaleni, either kweli le say right okanye ecaleni say left. That qualifies, you can go back and forth. That qualifies as an aldehyde. Aldehyde. One fact about the aldehyde, because a formyl group, it's always a ecaleni. We never mention the position of the formyl group because it's always a carbon 1. All aldehydes are always at carbon 1, E formyl group, functional group. Yes. So because of that, sne methanol, sne ethanol, sne propanol, sne butanol, pentanol, hexanol, all of them, because zizawube zicacile. So here is such example. Lena indoni yi-propanol. And also the propan 1-al, it's that propanol because position icacile ku carbon 1. You have to. All aldehydes, functional group is at carbon 1. If you remember, their general formula is CNA2N2NO. So what will be the functional molecular formula here? It will be C3H 3 times 2 6O. Now I jonga to see if it corresponds. And then I said and only just then the others I won't do. So basically here that is an aldehyde. Now here's a different story. Look at C double bond overlap between two carbon atoms. Because of that, it cannot be an aldehyde because the C double bond O all the time attached to a hydrogen for by the aldehyde. So this is not an aldehyde. So if you remember, or we can go back. If you remember, that is a ketone because the C double bond O between two attached to two other carbon atoms. So that is a ketone. So because of that, It means now we must name it according to ketones. Ketones is own. So 4. So it's about butan man, butan. But what? It's about butan 2 own. Because if say about at 1, 2, 3, 4, it closest square as the leftmost. Why? Because if ever I have 7, let me just use 7 carbon atoms, that C double bond O can be here. It be carbon 2, or it can be at carbon 3, or it can be at carbon 4. So hence we have to mention the position of that carbonyl group, because it can occupy any number of carbon atom, as long as in between, as long as it's somewhere here in the chain, that will make that a ketone. So kubani CnH2nO, general formula. So that makes this C4H8O, because 2 times forms. Yeah. So a ketone. And then back. So this molecule is an aldehyde. Why? Because anyhow, because there is a formyl group here. Difference between formyl group and carbonyl group. Carbonyl group, you see double bond O attached to 2 other carbon atoms. Then here, if formyl group, you see double bond O attached to at least not at least to one carbon atom. So essentially, this is a primary carbon atom. So, but there is also a branch here, because if I count the closest to the functional group is 1, 2, 3, 4, 5. The branch is at carbon 3, so that 3 methyl, sitting 5 carbon atoms, sitting pentanal. I forgot now. Pentanal. Why? Because for aldehydes, we don't mention the position of a functional group. Remember that. Anyhow, now almost the same molecule we are coupled, but now they moved the C double bond O to the second carbon atom. The minute we move it to the second carbon atom, notice this is a primary carbon. I mean to say secondary carbon. What that basically means, it attached to 2 other carbons. That means that now this makes this a ketone, because a ketone will C double bond O attached to 2 carbon atoms, So ketone. So again, apply rules. Closest functional group must have the lowest number possible. So now we must mention the position, because ketone we mention the position all the time. Yeah. So Q3, there's a methyl again. Methyl, ne? And then 5, pentan. But carbon 2, that's where the carbonyl group is at. 2 own. So 3-methyl pentan 2 only. Remember, CnH2nO. So that makes this C5H10O. Let me go back and here I did not mention because but CnH2nO. So that will make this C5H10O. So if you notice, these 2 molecules, they have the same molecular formula, but the structural formulas are different. So this is what you call an isomer, people. Yeah? But we'll do that later on. But I'm not making a mistake here. Their molecular formula is the same, but they have different structural formulae. I am going to explain this in the next lesson. Anyhow, physically, the functional group is not highlighted, but let us remember, if ever that C double bond O is at the terminal carbons, That will make that, and attached to a hydrogen, that makes that a 4-mile group. Now, it's a 4-mile group, really. So, a 4-mile group is aldehydes. Aldehyde. Then we count 1, 2, 3, 4, 5, 6. Remember, aldehydes always, if a functional group is at carbon 1, so we don't mention the position. So that makes this a hexanal. Hexanal. Physically, ketone. Why? Because C double bond O is attached to 2 other carbon atoms. 2 other carbon atoms. And because the ketone, I must mention the position here. So this is going to be 1, 2, 3, 4. I think I already did this. Butan 2 O. See, Lule? Okay. Here, that's 4-mile group. Why? Because C double bond O attached to H in the terminal carbon. So that's why I started 1. So I will call it right because it closest will call it right. 2, 3, 4, 5. So this is pentanal. See, Lule? Yeah, I already did this. This is butan 2-on. See, Lule? Yeah, this is a new homologous series now, that one. This is a carboxylic acid. Why? Because if you remember, a functional group of a carboxylic acids was called carboxyl group. Carboxyl group is C double bond O attached to OH. That's the key difference between carbonyl group, carboxyl group and 4-mile group, because the 4-mile group is attached to H. So we need to familiarize ourselves with the different key differences between the 2 homologous series. Anyhow, this makes this a carboxylic acid. So carboxylic acid, the general formula is CnH2nO2. And then we first number 1, 2, 3, 4, 5 because it's right, because that's where the functional group is closest. Now, again, just like aldehydes, carboxylic acids, always a functional group equal carbon 1, people, always. Or it's at the terminal carbon, it's a calene. And because of that, always, we don't mention the position here of the functional group. We do not mention the position of a functional group. Yeah. So this is going to be pentan. Pentan. Let me go back. I don't think I said this. There's something that I skipped here. Yes, I did. So I did give you all the suffix of the others, alcohols, aldehydes, and ketones, forgetting the carboxylic acids. A carboxylic acids, people, is suffix. It's supposed to be oic acid. So it goes along oic acid. So you just say oic acid. Oic acid. So because the functional group here is only carbon 1, we will never mention the position here. So methanoic acid, ethanoic acid, propanoic acid, butanoic acid, pentanoic acid, hexanoic acid, heptanoic. Yeah, that's the drill. So basically, I just need to, if there's no branch, I just need to count the number of carbons present in the molecule, then name it accordingly. So because I have 5 carbons here, let's make this a pentanoic acid. So kapala pentanoic acid. And the molecular formula is going to be C5H10O2. So if you verify Payana, it will match. This is the upper. Which one is this? There's a branch here. So kumbula rules zethu, when we count, we must count the longest continuous chain that occupies, that has the functional group. So kanibala apha that 1 nyanzelekile because right, because that's where the functional group is closest. Ndithi 2. Now I have 2 routes. I can say 3, 4, or I can say 3, 4, 5, 6. So icacile which one is the longest continuous chain. One has 4, one has 6 carbon atoms. Then that means that carbon 2 dine branch. Nansi le branch really. So now I must first name that branch. That is 2 ethyl, yeah people, ethyl. Then there are 6 carbon atoms here. That means hexanoic acid. Again, not making a mistake. For carboxylic acids, we don't mention the position of a functional group. So again, I have a carboxyl group that makes this a carboxylic acid. And then when I count that 1, 2, 3, 4, 5, 6, because bands up 5. So this is the longest continuous chain, is the straight one. And then we carbon 4 in a branch. So a branch I'm in methyl, 4-methyl hexanoic acid. Why? Because no need to mention the position of carboxyl group. This is the upper formyl group. Because of that, that makes this one a butanal. Yeah, because 1, 2, 3, 4. Yeah. So that is how you name the aldehydes, the ketones, alcohols, and carboxylic acids. The end of the lesson.